Here are a few more options for the regression procedure. So suppose I have this medical data set that we've been working with, and I want to get predicted values for each x point on my x-axis. I want to get predicted values at each of those points. I can use that P option. I can also get a confidence interval for the mean value at each x point. These are confidence intervals for a single predicted value, confidence intervals for an individual or a prediction interval. R gives me residuals. And I can also set my alpha to be something else. So for these two confidence intervals, I wanted a confidence interval with an alpha of 0.1, in other words, 90% confidence intervals. So that'll give me a few extra options when I run this. You can see I still get this analysis of variance at the top of the page, my parameter estimates as always, but then I get a few extra things, predicted values and standard error of the mean, confidence intervals, residuals, studentized residuals. And then I have a few output statistics. It also gives me, when I ask for the residuals, it gives me Cook's D and a little plot there, so I can check out to see whether my residuals are making a pattern. Another thing you can do, let me not make that a comment, is I can take all of those statistics that I found in the model and output them to a new data set. What this does is it adds all of these variables, the predicted and so on, to your original data set. So my original data set with the X and the hemo and gluc and so on and so forth, not just these two variables, not just the X and the Y, but all of the original variables will be in this new data set alongside all of these. I've got the CLM is, again, for the confidence interval for the mean value at each X point. This gives me the lower and upper values for that confidence interval. Same thing with the prediction interval for a single observation. That gives me lower and upper values there. H is the hat values. I got residuals, studentized residuals, the DF fits value, Cook's D. And then, as always, the blue stuff is keywords in SAS, whereas these black words, STUDR, that's a name that I made up, and you can call yours something else, Smiley, if you want. It doesn't matter what you call it. I'm going to call it RStud. Whatever your favorite name for that is. If something else makes sense, you use that. And then I'm going to go ahead and print this out so you can see what it looks like. And then you can see what kind of insanity I've got going on. These are all the original data values in through here. That's just the original data set. And then from here on, predicted, and then this is the lower end of the confidence interval for the mean, the upper value, and so on. And that just gives me something interesting so that I can play with those values now. For example, some people have been recommending that you take the residuals, take their absolute value, take the square root of that. So the square root of the absolute values of the residuals, or the standardized residuals, if you like those better, and then plot those against the original X variable that you had to see whether or not you have any problems in your data set, if there's any pattern in the residuals. And there you can see, well, okay, it looks pretty random for a small sample size, I guess. So that's one way you can do that. Another thing that you can do if you want, say your plot looks like this. You've got an X value here, an X value here, and one up here, and then you're plotting along, but then you don't have anything in here, and you want to know what value would be predicted at this particular point. And you don't know. So you can go ahead and fit the line, do the regression, but then you can add one point into the model that doesn't have a corresponding Y value. So if this is cholesterol and this is glucosamine, I said, well, I want at 153.2, I want my model to predict the glucosamine level of a person with a cholesterol level that high, but I don't actually give it a Y value there so that it won't mess up the model. So this regression model, in other words, will have the same parameter estimates as if I had run it on the original data set in COMED. And then you can see I just create this data set where I just make that X variable, and then data to TOG is the data set with just that extra point in there. And I'll go ahead and run it so you can see what happens. Oh, I have to create it first. And so you can see I've got this 153.2, but everything else is blank because I didn't set any of those values to anything. But I have the rest of the data set. And then when I run it, I get the same parameter estimates that I would have otherwise, except that since I didn't have any Y variable for that point, I get the same parameter estimates as I would have. But then it gives me the predicted values, in other words, the point on the line at that X value, and confidence intervals to go along with it.